Okay, we're going to jump to section 8 because it more nearly goes with section 3, the one that we looked at that introduced the idea behind functions. And what section 8 does is it introduces how different functions can be put together. And as I mentioned, one of the nice things about function notation is when I actually have multiple functions, instead of calling them all y equals, I can actually label each function differently. So I can say f of x for function f and g of x for function g and so forth. So the first thing section 8 introduces is how we can kind of abbreviate the way we add functions. So as you can see here, we have f of x and g of x equals f plus g of x. F of x minus g of x equals f minus g of x, and so forth. Anytime you put two functions together, it's automatically multiply, and of course the line underneath can give us the divide. So here we have a couple of functions, f of x equals x plus 3, and g of x equals 2x minus 1, and we want to find f times g of 2 and f minus g of 0. And honestly, the easiest way to do this is to find out what f of 2 and g of 2 are, and then multiply the two together. Or in the second case, find out what f of 0 is, and then what g of 0 is, and then do our subtraction. And so that's just what we have, f times g of x of 2, and so f of 2 times g of 2, and when we plug them in, 2 plus 3, that gives us the 5, 2 times 2 minus 1, that's 3, 5 times 3 gives us our 15, or if we put in the 0, 0 plus 3, that gives me a 3, 2 times 0 minus 1 will give me negative 1. 3 subtract negative 1, of course that becomes add, and we get 4. Slope, which is defined as the rise over the run, or the difference in the y values divided by the difference in the x values, can be rewritten in this form, in which instead of the y's, we now have f of x2 subtract f of x1. When it's in function notation. And then m can also be written this way, in which we have replaced the x2 with x plus h, in which h is some difference from x. And this is called the difference quotient. And so it's written this way: the slope equals f of x plus h minus f of x over h, because of course the x's will cancel in the denominator. When multiple functions are used, they may be identified with f of x, g of x, h of x. Generally, we start at f and then we go alphabetical. In function notation, x can be anything including another function. So if you have f of g of x, as I have written here, then that just means that wherever I have an x in f, I'm now going to put in g of x. I'm going to put in whatever the function g of x was. So for instance, let's suppose that f of x, again, it's just another way of saying y, f of x equaled x minus 3 squared, and g of x equal 2x. So f of g of negative 1 would read as g of negative 1 would be solved by first solving the g of negative 1. So we're going to put in negative 1 here, which would give us negative 2. And then that answer would be then put into the f function. And so, again, 2 times negative 1 gave me negative 2, f of negative 2. I put that into the other equation. Negative 2 subtract 3, negative 5. Negative 5 squared, of course, is 25. When you have it written in that form, f of g of x, and of course you can go just beyond 2, it is called a nested function and are always solved inside out, or if you will, we're going to start on the function that's to the right and then work our way backwards to the left. So f of g of h of 1 first solves h of 1, then puts that result into the g of x, and then whatever that result is then gets put into the f of x last. In most cases, changing the order f of g of x versus g of f of x will not give you the same result. They are not equal. And then finally, composite functions are another way of combining two functions. Here, this would actually read as f of g of x, or the little o, if you will, is for the of. Sometimes people will pronounce it fog of x, and it means the same thing that it does here. It's just a little bit handier way of writing it, where the results of g are again used as inputs for f. So in this case, again, if we let f of x equal x minus 3 squared and g of x equal 2x, then f of g of 2 equals f of g of 2, which is f of 4, which is 1. So that's the only new things to be added in section 8. The rest of it are just some examples so that we can see how these problems are solved. So first, and really, the thing to understand about all of this is it's another way of writing things. It's sort of an abbreviated way of writing things so that you just don't have to write everything out. Anybody who uses a spreadsheet will do things similar to this, in which they put a function in one cell, and then that refers to some input from another cell, and then those things may be used in a third cell. So it's just a matter of writing out, if you will, the code in a more abbreviated style, but it's still doing the same math. All right, so again, the easiest way to approach a problem like this is we're first going to find out f of 0. Here's our f, so 3 times 0, subtract 5. Of course, anything times 0 is 0, so we get a negative 5. Okay, now I'm going to do my h of 0. So here's the h. So that's 3 times 0 squared, which of course is still 0. So f plus h of 0 is going to be negative 5 plus 0, which is negative 5. Okay, here we're going to do a divide. So first I'm going to find the g of negative 3. That's the middle one. So I got negative 3, subtract 2, which is negative 5. Now I'm going to do the h of negative 3. So this is 3 times negative 3 squared, which is going to be 27. So g over h, or g divided by h, of negative 3 is going to equal negative 5 over 27, which in this particular case will not reduce. So there was my answer for the first one. Here's for the second one. All right, now we're going to do subtraction. F of negative 1. So 3 times negative 1, subtract 5, which will be negative 8. G of negative 1, which will be negative 1 subtract 2, which is negative 3. So f subtract g of negative 1 is going to equal the negative 8 subtract the negative 3, which will give me negative 5. Because subtract a negative becomes an add. And then here, anytime you have letters next to each other, it's automatically multiplied. So f of 5, 3 times 5 minus 5 is 10. G of 5, 5 minus 2 is 3. So f g of 5 will be 10 times 3, which is 30. And so there are our first examples. Now we'll do some in which they're nested. So remember, you're always going to do the one inside or one to the right first and then work your way backwards. So here I first have to do f of 2. So I got 2 times 2 squared, subtract 8. So that's going to give me 0 for that one. And then we're going to do the g. But for the g, I'm going to put in that 0. And so I'm going to have 1/2 times the 0 plus 1, which is just going to give me 1. So there's my answer to number 5. Okay, now this time I reverse the letters, so I have to do them in the opposite order. So first, I'm going to do g of 2. So 1/2 of 2, of course, is 1. 1 plus 1, and I get 2. And then I'm going to do f, and I'm going to take that 2. So in other words, the part I found in the first function now becomes what I put into the second one, and of course 2 squared, subtract 8, and I end up with my 0. And so as you can see, reversing things did not give me the same answer. Okay, here we have 3 of them, and yes, I know f comes before g comes before h, but we're going to do the one to the right first. So first we're going to do the h. And so that'll be 6 times the negative 2, subtract 2, which is negative 14. Then I'll do negative 14 into the g. So we'll have 1/2 of the negative 14 plus 1, which is going to give me negative 6. And then the f last. So now I put in the negative 6. So I'm going to have 2 times negative 6 squared, subtract 8. So 36 times 2, 72. 72 subtract 8 is 64. And there is my answer for that one. The output of one becomes the input of the other. Now, again, mostly this chapter or this section is just trying to introduce a different way of saying the same thing. So, doing f of g of 2 and over here doing fog of negative 1, that's kind of the same thing. In other words, this really is equal to f of g of negative 1. Just a different way of writing it. So, first I'm going to do the g of negative 1. So, negative 1 plus 1, that is 0. And now I'm going to do the f of that 0 that I just got as output. And so I have 0 subtract 2 squared, which will just be 4. And then here I switch the letters. Sometimes we call that fog of -1, here goff of -1, but again, switching the letters won't necessarily get the same result. So now we're going to do the F first. So -1, subtract 2 squared. Well, that's -3. -3 squared is 9. Now we'll do the G out of the 9 that we just found. And of course, we're going to have 9 plus 1. And so we end up with 10. All right, the very last part just gives an example of finding the difference quotient. So again, the difference quotient looks like this. And we're going to use this for our f of x. So that means in the first place, everywhere we had an x, we're going to put in x plus h. So x plus h squared minus 3 times x plus h. So that represents this part right here. And now we're going to subtract just the f of x. So subtract x squared. In fact, I'm going to put it inside parentheses, subtract 3x. So, and then all of that is over h. Now, when I FOIL this part and distribute the other parts, I'm going to end up with x squared plus 2xh plus h squared minus 3x minus 3h minus x squared plus 3x. And again, all of that's over h. Now, it turns out those x squareds go away. The 3x's go away. And I now have a result of 2xh plus h squared minus 3h all over h. And so I can do the canceling, h with those two guys and with the squared, and the end result is m equals 2x minus 3 plus h. And that would be the difference quotient. So just an example of that. And so that is section 8. More practice dealing with functions and the way functions are written.